Hello, everybody, and welcome to week 1 of our online astronomy course. This is Sunday, it's January 9th, 2022, so Happy New Year to you. And I hope you're looking forward to this course as much as I am. Now, before I get into Module 1, I want to talk about the astronomy news that's been going on this week. And the big astronomy news this week has been the successful deployment of the James Webb Space Telescope. This is a successor to the Hubble Space Telescope. James Webb Telescope has a mirror that is 7 times larger as far as area goes, 7 times larger than the mirror of the Hubble Space Telescope. That means it's a much bigger light bucket to capture the light that comes in from distant stars and galaxies. Not only that, but the mirrors are sensitive to infrared light. Now, infrared light is also called heat radiation, and it happens that if you have young stars that are just forming, they're buried inside clouds of gas and dust. And you can see some of those clouds of gas and dust in the picture behind me here. This is a picture of Summit Lake in California. It's in Lassen Volcanic National Park. And I took this back in September of 2016. And in fact, you can see over my shoulder here, that light that's on the shore is a lantern inside my tent. But this is a picture I took of the sky that's in fact reflected in Summit Lake. And over my shoulder here, you can see the edge of our Milky Way galaxy. Actually, I shouldn't say the edge, I should say the center of our Milky Way galaxy, because our Milky Way galaxy is in a plane. It's a flat disk of stars. And we aren't in the center. We're sort of out in the suburbs, and we're looking in toward the center. And right here, you can see that we're looking in toward the center. But you see some regions where you can see these sort of dark clouds, and these are clouds of gas and dust. And not Hubble, but the James Webb Space Telescope, being sensitive to infrared light can come out through that dust and reach our eyes, whereas visible light would be blocked. And so the James Webb Space Telescope will let us look inside those clouds and see how stars are being formed. It's pretty cool. So let me get back to the James Webb Space Telescope. It was launched on Christmas Day last year. And since then, it has been sailing away from us. It has sailed out beyond the moon. It's going to end up about 4 times as far away from Earth as the moon is. So 4 times the moon's distance. Why does the Webb Space Telescope have to be out that far? Well, it looks at infrared radiation, which is heat radiation, and the heat given off by Earth and the moon would blind the James Webb Space Telescope. That means that it has to be far away. And so it's going to travel out far from Earth and far from the moon. So it's not affected by the heat given off by Earth and the moon. Now, you can't get away from the sun. The sun is still out there. So the James Webb Space Telescope has this huge sunshade that is between the telescope and the sun. Now, this telescope is huge, and it had to be sent into space with a rocket, so it had to all fit in to the nose cone of that rocket. So it had to be folded up like origami. And since it's launched, it has been slowly unfolding in space. Now, I want to show you a short video of just what that unfolding looked like. So let me bring that up. I'll share the screen and take a look at this unfolding video. So here we go. I think I can just make this a full screen video, why not? And we'll play that. So here is the James Webb Space Telescope, what it looks like when it's all unfolded, but this is how it's folded up to fit into the nose cone of the rocket. And so 31 minutes after the launch, some solar panels are deployed and an antenna is deployed down there on the bottom to talk to Earth. Then the sunshade folds down. Now the sunshade has to stretch out to block the sun. And so now other things are being deployed. The telescope was raised up a bit, and now the sunshade's going to be pulled out from the sides. And that sunshade is going to be between the telescope and Earth. You'll notice that the mirrors of the telescope look gold. And that's because the mirrors are actually coated with a thin layer of gold, because gold reflects infrared light. And so for an infrared telescope, gold is an excellent element to cover the mirrors with. Now the sunshade has been deployed. The little secondary mirror has been put out in front of the telescope. That reflects light from the telescope to the secondary mirror to the instruments at the center. And now two wings are being folded out in place. And now the telescope is complete. That was just completed yesterday. And so it was very exciting. There were 344 things that had to go right, because if one of them didn't, the mission would be just terribly compromised. And so far, all of them have worked. It'll take about 29 days from the launch on December 25th out to January 29th for the James Webb Space Telescope to reach its final position. And then it's going to take about 6 months till the end of June to cool down enough that it's not blinded by its own heat. So what a fantastic instrument this is. And I'll be telling you some more about this in coming weeks. So now let's talk about Module 1. Okay. Module 1 is about a preface, an introduction in the book, and it's chapter 1 in the book. And this just talks about the night sky. So what do we see in the night sky? Look at all these stars you can see above Summit Lake right here. Oh, and you can also see 2 planets. Right here is Mars, and right over here is Saturn. So there's 2 planets in this picture as well. And even the ancient Greeks knew that the planets were different, because from night to night, the planets would move across the stars. So one night, Mars might be here, and then it might be here, and then it might be here. And so it moves through the distant background stars. And so does Saturn. So Mars might move this way through the stars, and Saturn might move a little bit slower this way through the stars. And the Greeks couldn't understand why this was. So they named these objects after the Greek word for wanderer, which is planet. So planet actually tells you, the word planet actually tells you what these objects are doing. They are wandering through the stars. Now, in Module 1, also, we'll be talking about vocabulary. And there's some vocabulary having to do with science. Science, you'll find out in astronomy, has a very specialized vocabulary. Sometimes words don't mean what they mean in just ordinary everyday English. And those are words like theory and law and hypothesis. Those words mean something different in science. And so you'll learn about what those are. Also, in this module, you'll be studying the phases of the moon. The moon looks different from night to night because as the moon orbits Earth, always half of the moon is lit up by the sun, but depending upon where the sun is relative to Earth and the moon, we see different amounts of the lit side and different amounts of the dark side. And those go through a series of phases. And so you'll be learning about those phases of the moon. Sometimes either the moon will get between the sun and the Earth, in which case there is a solar eclipse. The moon can block out the sun's light. Or sometimes the Earth gets between the sun and the moon. In that case, the moon can pass into Earth's shadow, and that's called a lunar eclipse. And you'll learn about those things too. Also, in the introduction to Module 1, there's some exercises for your calculators, because there is some math in these homework assignments. And this calculator exercise will just help you make sure that you can use whatever calculator you're using. So take a look at that. Now, that is Module 1. There's some cool videos to watch as well. And before I go, I want to talk about a little bit about what is in the sky tonight. So I'm going to pull up Stellarium. And here's Stellarium. This is set for January 9th. This is military time, so this is at 9 p.m. tonight. Now the moon will be moving night to night, but otherwise the stars will look just about to be in the same position this week. So there's the moon, and this is the first quarter phase of the moon. You're looking south right here. I hope you can tell. Here's south. Over on the left side of the screen you're looking to the southeast. To the right of the screen, you're looking to the southwest. But there's the moon. And so let's zoom in on the moon. There we go, just zooming in on the moon a bit. There it goes. And you can see the moon is exactly half lit up. That means the moon has gone 1/4 of the way around its orbit around Earth. And that we call this the first quarter phase. So let me zoom back out of this again. There we go. And there's some really cool things in the sky right now. Let me just turn over here looking toward the east. And if you go out tonight, you'll see the constellation of Orion. So this is the constellation of Orion. This is one of the constellations you have to know for your Constellation Quiz. This star is the red giant star Betelgeuse, and you'll be learning all about these giant stars. Here's blue-white Rigel. Down here is Sirius. It's the brightest appearing star in the sky. Now, for your Constellation Quiz, you have to know 2 star clusters. Up here, if I just follow the 3 stars in Orion's belt, you come to Aldebaran. And around Aldebaran is the Hyades star cluster. And if you go a little bit further away from Orion, you get to this little grouping of stars, sometimes called the Seven Sisters. Those are the Pleiades. The Pleiades star cluster is right there. So go out and take a look at the sky tonight. It should be clear this week, so go around 9 o'clock or so and take a look at Orion. So that is it for this first week. Hope you enjoy learning about the night sky, and I will look forward to seeing you next week. So until then, bye-bye.